Hello everyone, I am t.swathi, DL in Physics from TTWRDC Mahbubnagar. Today I am going to discuss Newton rings. Newton rings are nothing but the interference rings formed by two reflected beams. And these rings were first observed by scientist Newton, hence they are termed after his name Newton rings. Okay. Interference. Let us start with the definition of interference. Okay. Interference is nothing but superimposition of two monochromatic and coherent beams. When two monochromatic and coherent beams superimpose, then there is a modification in the amplitude or intensity of the resultant wave. Okay. So the superposition can be occurred between any waves, but if the superposition is occurred between two monochromatic and coherent beams, then we are terming that as, or we are naming that as interference. Okay, so let us start the basic definitions of monochromaticity and coherence. Monochromatic is nothing but if two waves are having same frequency, then they are said to be monochromatic. So we can obtain monochromatic waves with the help of a sodium vapor lamp or with the help of laser sources. Coherence. Coherence is nothing but maintenance of constant phase difference between two waves. Maintenance of constant phase difference between two waves. Okay. So in the previous classes, we discussed very clearly that it is very difficult to maintain coherence or to maintain a constant phase difference between two waves which are having same frequency but are emitted by two different sources. Two waves which are having same frequency but are emitted by two different sources. Then it is very difficult to maintain coherence. So in order to get the coherence between two waves, definitely we need to derive two waves from a single wave. We need to derive two waves from a single wave. So this can be done in two ways. One is amplitude division and other is wavefront division. So wavefront division and amplitude division were discussed in the previous classes, and also we have studied the interference with the help of wavefront division in case of biprism and in case of Lloyd's mirror experiment. Now in these Newton rings, the wavefronts are obtained by the phenomenon of amplitude division. Hence, I taken the name as interference by amplitude division. Okay. Next, I will go with the experimental setup. And the theory of this Newton rings. Let us start with the experimental setup. See this. This is a sodium vapor lamp, which is source of monochromatic waves. So the light from the sodium vapor lamp are taken and are passed through a narrow slit. So the purpose of this screen or a slit, you see, so screen with a slit. Okay, so the purpose of this slit is to make the beam into a narrow beam. Though this is a narrow beam, this is a diverged beam. So to make this diverged beam into a parallel beam, here we are using a lens, a double convex lens. So a double convex lens will make the diverged beam into parallel beam. Okay, so we have got parallel beam of rays. So these parallel beam of rays were incident on glass plate, which is inclined at 45 degrees. The glass plate is inclined at 45 degrees. So the rays will incident at an angle of incidence equal to 45 degrees. Now these rays will partly reflect and partly refract. So angle of incidence equal to 45 degrees, therefore angle of reflection is also equal to 45 degrees. Total, the angle between the incident ray and reflected ray will become 90 degrees. So the horizontal rays of light are converted into vertical ray of light. Now these vertical rays are directed towards these vertical rays are directed towards a lens and glass plate system or arrangement. A lens and glass plate arrangement. How we will do this one? Let us see. See this diagram. So we have taken a glass plate and a plano-convex lens. Now on the glass plate, the plano-convex lens is arranged such that the curved surface of the lens will touch the glass plate. So the lens and glass plate will touch at point A, and after that there is a formation of air film between the glass plate and lens. There is a formation of air film between the glass plate and lens, plano-convex lens. And here the air film is not having uniform thickness. The thickness of the air film will gradually increase from point A. At point A, the thickness of the air film is 0. And if you move on, the thickness will gradually increase. Okay? This is how we will arrange the lens and glass plate. So, after this, above this we have a traveling microscope here. The purpose of the traveling microscope is to measure the radius of curvature of Newton rings and also to view the Newton rings. So we will observe the Newton rings from the telescope or a traveling microscope, and the rings are like this. You will observe the Newton rings like this. Why we are getting this one? Let us discuss what happens in this one. So, when the ray of light is incident on the lens and glass plate system, see this, first one, see the rays are parallelly moving. The rays are completely vertical and top of the glass plate is completely plain one. So, lens, top of the lens, not glass plate, top of the lens is completely plain one. So, as this is plain, what happens? The angle of incidence is equals to 0 degrees. So, angle of reflection is also equal to 0 degrees. So, the rays will move in the downward direction and they will move as it is in the upward direction, where at the top of lens and glass plate system, at the top of lens and glass plate system only. Okay. After that, what happens? So, here we will get incidence and reflection in the same direction. When it enter into the glass plate, obviously it will change its direction little bit, refraction, and it will travel in the lens. After reaching to the bottom of the lens, to the point B, after reaching the bottom of the lens, what happens? There is a change in the medium. So, what happens? Part of the light will reflect and part of the light will refract. Part of the light will get reflected and part of the light will get refracted. So, you are getting the reflected ray R1. So, the BD is the refracted ray. After reaching to the point C, what happens? Once again, there is a change in the medium. Hence, part of the light will reflect and part of the light will refract. Now we have got two reflected rays. One is R1 and the other is R2. One is reflected by the bottom of the lens and one is reflected by the top of the glass plate. Now these two rays are derived from single ray SB. These two rays R1 and R2 are derived from the single beam SB. Hence, they will maintain coherence. So, already they are monochromatic and now we have got coherence condition. Therefore, depending on the path difference between R1 and R2, they will either constructively superimpose or destructively superimpose. Okay. So, this is how after superimposing you will get the interference pattern like this. Why we are getting Newton rings, that we will discuss at the last. Okay. Next I would like to obtain an expression for condition of constructive interference and condition for destructive interference. So in the first classes of interference, we have studied that in order to get constructive interference, the path difference must be n lambda or 2n lambda. And in order to get destructive interference, the path difference must be 2n plus 1 into lambda by 2. 2n plus 1 into lambda. Okay. So odd multiples of lambda by 2 or even multiples of lambda. n lambda for constructive interference undali. 2n plus 1 into lambda by 2 destructive interference undali అని మనం previous class లో చదువుకున్నాం. ఇప్పుడు ఏంటి అంటే there is a change because we have studied that whenever the rays are reflected by a denser medium, there is a change in the phase of the waves. So because of that, there is a change in the conditions for constructive interference and destructive interference. So here, in order to derive this, we will basically take the condition from cosine law. In cosine law, we have studied that the condition for constructive interference is 2n plus 1 lambda by 2 and the condition for destructive interference is n lambda. Okay, 2n lambda, sorry. The condition for destructive interference will become 2n lambda. So by using that, let us take the condition for constructive interference and destructive interference in case of Newton rings. So condition for constructive interference. So we know that the condition for constructive interference in case of cosine law, means which were reflected by glass plate, is 2 mu t cos theta is equals to 2n plus 1 into lambda by 2. What is mu? Refractive index of the medium. What is t? Thickness of the film. What is theta? Angle of incidence. Okay. What is lambda? Wavelength of the light. So here, just before I said that the angle of incidence is equals to 0 degrees. Therefore, as the angle of incidence equal to 0 degrees, I will get the condition as 2 mu t is equals to n plus lambda by 2. 2 mu t equal to n plus lambda by 2 because cos 0 is 1. Okay. Next, what is the film here? Air film. What is the refractive index of air film? 1. Therefore, the condition will become 2t equal to 2n plus 1 lambda.
Done.
But really in practice we have 2n plus 1. Okay. 2t equal to 2n plus 1 lambda by 2 is the condition for constructive interference in case of Newton rings. And let us discuss the condition for destructive interference. So in case of cosine law, we know well that the condition for destructive interference is 2 mu t cos theta equal to 2n lambda and 2 mu t equal to 2n lambda because their theta is 0 degrees, cos 0 is 1. Therefore, you will get 2 mu t equal to 2n lambda, 2 will get cancelled and the refractive index of air is 1. That's why you will get the condition for destructive interference as t is equals to n lambda. T is equals to n lambda. So, now I would like to obtain an expression between the diameter of the Newton's rings and radius of curvature of the lens. So, what is a lens actually? A lens is nothing but a part of the spherical sphere. A lens is nothing but a part of a sphere. So, we have imagined that the lens is taken from a sphere which is having radius of curvature r. So, O dash to O is r and similarly O dash to L is also equal to r. So, next I took a Newton ring at point L, means there let us suppose that the thickness of the air film is t and let us suppose that the radius of the ring be r. The radius of the ring be r or rn, nth ring. I have considered here the nth ring. That's why the radius of the ring will become rn and the thickness of the air film is t. So, simply I got there a right angled triangle O dash ml. So, if I apply Pythagoras theorem, what will become? Hypotenuse O dash L, adjacent side O dash M, opposite side ML. Therefore, Pythagoras theorem, if I apply O dash L square equal to O dash M square plus ML square. What is O dash L? Radius of the curvature, radius of the lens, radius of the sphere, or I can say. So, what is O dash M? Actually, the thickness of the air film is T, but O dash to O is capital R. O dash to O is capital R, but I need only O dash to M, and clearly M2O is thickness of the air film. M2O is thickness of the air film. That's why I will get the distance O dash to M as R minus T, because O dash to O is R, not O dash to M. So O dash to M will become R minus T. And ML is nothing but radius of the Newton's ring, which I took as Rn. So Rn square. If I expand this, what will become? It will become capital R square is equals to capital R square plus T square minus 2 capital R T plus Rn square. So I will get cancellation of R square and R square then. So what will be left? Rn square will be this side and remaining terms will go to that side. So what I will get? Rn square equal to 2 capital RT minus T square. See, here the thickness of the air film is really very much less than the radius of curvature of the sphere or lens, radius of curvature of the lens. So as the radius of curvature of the lens is very large and the thickness of the air film is very less, so I can neglect T square. I can neglect T square. So if I neglect T square, what I will be left with? Rn square is equals to 2 capital RT. Okay. So what is Rn there? Radius of the Newton ring. So if I want to calculate diameter is nothing but twice the diameter is nothing but double the that's why I'll get dm square is equals to 4 capital R T. Okay. See this. So after getting that, so the general expression for thickness of the air film will become 2T equal to d square by 4R. 2T equal to d square by 4R I will be left with. So the diameter of the mth film, the diameter of the mth film will become 4R m lambda, and the diameter of the nth film, will become here dark rings I considered here. That's why I took it as m lambda 4R equal to m lambda 4R m lambda. Okay, sorry. So substituting these two, subtracting these two, dm square and dn square, what I'll get? dn square minus dm square equal to 4R into n minus 1 into lambda. Lambda equal to, simply by doing mathematical arrangement, I will get the expression for lambda. So the application, the basic application of Newton rings is nothing but to determine the wavelength of unknown source. So I got the expression for wavelength of the unknown source. The wavelength of the unknown source. Okay. So what is dn? Diameter of the Newton rings. What is nth ring of Newton's rings? And dm is the diameter of the mth Newton ring. Diameter of the mth Newton ring. N and m are simply the number of rings. 4R. 4 is nothing but 4. R is nothing but radius of curvature of the lens. So radius of curvature, if we know, we can easily calculate lambda. D and dm can be calculated with the help of travelling microscope. This is the main application of Newton rings. And finally, I would like to discuss why Newton rings are circular. So see this, clearly here we mentioned that the path difference between the reflected ray and incident ray depends upon the thickness of the air gap between the lens and the glass plate. This is obvious. As the lens is symmetric, this is the main important one. As the lens is symmetric along its axis, the thickness is concentric along the circumference of the ring of a given radius. If you take any ring, the circumference, if you take any ring, the thickness of all the points on the rings will be same. The thickness of the all the point is same, or I can say the locus of the points which are having same thickness will constructively superimpose. They will give some bright ring. The thickness of the locus of the all points which are having same thickness will destructively superimpose, and they will give a dark ring. Hence you will get Newton rings as circular one. Thank you.